The objective of this lesson is to explain and prove the accuracy of fraction multiplication products using area model drawings. The first equation we will prove accuracy with is 5/4 times 2/3 equals 10/12. Take the first fraction, 5/4, and draw 8 rows. The reason for the 8 rows is because 5/4 is a fraction greater than 1, and the denominator, our whole, is fourths, so we will need 2 groups of fourths to make our drawing. Because we are working with fourths, we will label 5 rows as 1/4 for a total of 5/4 and darken the last 3 rows we will not be using. For the second fraction, 2/3, we will use columns in our model. We will draw 3 columns because the denominator is thirds. We will label 2 columns as 1/3 and darken the last 1/3 of the column. If we write the fractions on the left and the top of the columns and rows, we can find the product of each square. 1/4 times 1/3 equals 1/12, so each box represents 1/12. Counting up all those squares, we have 10 1/12 squares, which equals 10/12. Our last goal is to explain how the equation relates to our model. The numerator's 5 times 2 represents how many we have, or 10, and our denominator represents how big is one whole, so we have 10/12. Let's use the equation 3 1/2 times 3/4 with a mixed number and draw a model and explain each part and how it relates to the model. Take the first fraction, 3 1/2, which is a mixed number made up of 3 wholes or 6 halves plus another half to equal 7 halves. We will label 7 rows as 1/2 for a total of 7 halves. The second fraction, 3/4, we will use columns in our model. We will draw 4 columns because the denominator is fourths. We will label 3 columns as 1/4 and darken the last fourth of the column. 1/2 times 1/4 equals 1/8, so each box or unit is 1/8. Counting up all those boxes, we have 21 boxes of 1/8 or 21/8. Our last goal is to explain how the equation relates to our model. The numerator 7 times 3 represents how many I have, or 21. The denominator 2 times 4 represents how big is one whole, in this case 8ths. In total we have 21/8. The mixed number would be 2 wholes and 5/8. Remember, to make better sense in solving fraction problems, it is good to ask what the numerator represents. How many do I have? And what the denominator represents. How big is the whole? The objective for this lesson was to explain and prove the accuracy of fraction multiplication products using area model drawings. We met this objective by drawing and labeling models of the fraction equations.